Alright. This rule is the simple power rule. The power rule we've been using in 99, 102, and 103 to graph simple parabolas, or and later on we graphed harder polynomials with it. But the basic rules for it is that you got the derivative with respect to x of the value x to the n is equal to x in x to the n minus 1. So really all you're doing with this power rule is you're subtracting one, you're using the exponent, multiplying the coefficient, right? Whatever the coefficient might be, and then subtracting 1 from that exponent. And if you have them adding each other, then you're going to do it to each one as you're adding. And that's called, you're going to incorporate what's called these the addition, subtraction rule, sum and difference rule, derivatives of sums and differences. So in the same thing, we're going to take that rule, and basically we're saying that f prime of x plus, or f of x plus another g of x or whatever, plus, and what you're doing is when you add those, you're just going to be finding the f prime x plus g prime x. So in that essence, all you're doing is this same rule, as long as they're adding or subtracting each other. Okay? So let's look at an example of what I'm talking about. 3x squared plus 4x minus 5. All different numbers, so we should be able to see what's going on. In this rule it says, okay, I'm going to take the exponent times the coefficient, so 2 times 3, and subtract 1 from the exponent. And look at the next piece of the not the parabola, in this case it is, but the next piece of the polynomial, and do the same thing. 1 times 4 to the x to the, and there's a 1 up there, and it's minus 1. And then at the end here, oops, minus 5, and really there's an x to the 0. Okay, so really there's an x to the 0 up here, so what you really have is minus 5 times 0 times x to the 0 minus 1. So what happens there is that 2 times 3 is 6. 2 minus 1 is 2. No, 1. Okay, late in the day, 12 hours, give me a break. 1, no food. 1 times 4 is 4, and 1 minus 1 is 0, so you really have x to the 0, right? And this is minus 0 times x to the negative 1. Now, the thing is, so what the thing is what this is really just 6x. What this is really just 4. And what this is nothing. So, what we like to say is the derivative of a polynomial, right, of x to the n plus x to the m plus a constant, okay, can be looked at as just, or let's just say x. So this would just be or let's look at this as a 2. So let's take this as a constant. Sorry, let's take this as a constant and just go, okay, the derivative, if this is f of x, then the f prime of x is going to be just 2x plus whatever constant's out in front. In this case, it's 1. The constant, in this case, goes away. Okay?
So why is it x squared
So,
again?
oh, I just made this up. This is just another way to show that every time you deal with a polynomial of some sort, you take this, bring it down, subtract 1 from it, and at the time when you get to the constant goes away, and what's left is the coefficient. Okay? In front of the last x. So whatever that last x is. A lot of times the way they like to show this is like f of x is equal to x to the n. Oops. Sorry about that. Ax to the n plus plus bx plus c, and then f prime of x would equal n a x to the n minus 1 plus plus b. That's it. So your new constant would be b, and then there's whatever's in between these. You know, it just can go on for however many pieces it can go on for. So when you do it, it's just really, really simple. Let's look over here. Am I recording? Good. I'll make a big long one. You can help me through it. 5x to the 4th minus 2x to the 3rd plus 4x minus 6. Oh, that was big and long, right? Anyway, what's this first one?
I'm still trying to write. Right. It'd be 4 times 5.
Yes, 4 times 5 is
20.
20x to the... So this is f of x, and this is f of x prime. 20x to the 3rd minus
6 to the 2nd
good
plus 4.
plus 4.
Plus 4. Minus 4. You got minus.
Oh, plus 4. So why is it just 4? Because that was an x squared. It's kind of tricking you. It's just x to the 1. So when you subtract 1 from 1, I mean, it's none. So there's none left. Okay? And you can keep doing this. Double prime. Write it in red. What is it? 60. X to the
Squared.
2 minus
12.
x, yeah. Now there is no constant. Your constant in this case is 0. Plus 0, right? Because the constant goes away. Okay. F triple prime. So 120 x minus, no, 12. X quadruple prime.
$120.
120. F of x to the 5th prime.
Zero.
0. There's no x, right? Okay? That make sense?
Could you just do
Yeah.
one more?
Of course.
And I think I'll have it.
One more power rule. We got 5 minutes. We can do that. Go ahead. Alright. So, another one. Eight x to the fourth minus 2x squared plus 4x minus 1. F of x, f prime x, f double prime x, f triple prime x, x quadruple prime x. Let's do them. So we got 32, you said? X to the x to the
Squared. Or
third
my bad.
minus
4x.
4x to the
Plus 4.
plus 4. Good. Didn't trick you. Okay. Next one.
64x squared.
Nope, nope.
Nope, nope.
Close.
Oh,
It's a
3.
6.
Whoops. I times it by 2, not 3. My
Yeah.
fault.
96x squared. Good. Minus 4. Good. Okay. Then what?
192x. 192x.
Yep. 192x. Is that it? Then what?
192.
192. Then what?
0.